Ever wondered how statisticians categorize the vast amount of data they work with? Well, let's dive right into it to uncover the mystery of data types. If you have not subscribed yet, this is your time. Imagine you're a detective, and your job is to make sense of the world around you. In the realm of statistics, data is your evidence. It's the clues you collect to solve the mystery. But not all evidence is the same, right? Just as a fingerprint differs from a DNA sample, data types vary too. The way we classify this evidence, or data, is what we call data types. So why is understanding these data types so crucial in the field of statistics? Well, think about it. If you're trying to solve a mystery, you need to know what kind of clues you're working with. Are they fingerprints, DNA samples, or something else entirely? Similarly, in statistics, understanding the type of data you're dealing with can help you choose the right tools and methods to analyze it, and thus solve your mystery. But here's the thing. Data isn't just numbers. It's a blend of numbers, words, codes. It's a mix of quantitative and qualitative information. Quantitative data is numerical. It's something you can measure or count. Qualitative data, on the other hand, is descriptive. It's something you can observe but not measure. Within these two broad categories, we have subtypes. For instance, quantitative data can be discrete or continuous. Discrete data is countable, like the number of students in a class. Continuous data is measurable, like the weight of an apple. Qualitative data also has its own subtypes, nominal and ordinal. Nominal data can be grouped but not ranked, like the type of fruit a person likes. Ordinal data can be both grouped and ranked, like rating a movie on a scale of 1 to 5. And we're just scratching the surface here. There's a whole universe of data types to explore, each with its own unique characteristics and uses. Stay tuned as we unravel the different types of data in the world of statistics. Quantitative data, ever heard of it? Well, even if you haven't, you've likely been interacting with it more often than you think. Quantitative data is all about numbers and measurements. It's the kind of data that you can count or measure, and it can be directly verified. Now, there are two main types of quantitative data: discrete and continuous. Let's start with discrete data. This type of data can only take certain values. Think about the number of people in your family. You can't have 2.5 people, right? The number has to be a whole one, 1, 2, 3, and so on. So, the number of people in your family, that's an example of discrete data. Next up, we have continuous data. This type of data can take any value within a given range. Picture the weight of your pet dog. Your dog doesn't just weigh 4 or 5 kilograms. It could weigh anywhere in between, like 4.3 kilograms or 4.9 kilograms. The weight of your dog, that's an example of continuous data. You may also come across two other types of continuous data: interval and ratio. Interval data has meaningful differences between measurements, but no true zero. Think about temperature. 0 degrees Celsius doesn't mean there's no temperature, right? It's just another point on the scale. On the other hand, ratio data has both meaningful differences and a true zero. Consider the money in your bank account. If you have $0, it means you literally have no money. And the difference between $10 and $20 is the same as the difference between $70 and $80. So as you can see, numbers aren't just numbers. They carry different types of information depending on how we use them. And understanding these different types of quantitative data can help us make sense of the world around us. So that's how numbers play a vital role in the realm of quantitative data. But wait, there's more to the story of quantitative data. Yes, you heard it right. Not all quantitative data are created equal. So let's delve deeper into the world of continuous data, which is a subtype of quantitative data. Now, continuous data can be further divided into two subtypes: interval and ratio. You might be wondering, what's the difference? Well, let's break it down. Let's start with interval data. The word interval might remind you of the gaps or distances between things, right? And that's exactly what it is. Interval data refers to values or observations that have an order and a specific, consistent scale, but no clear starting point. Think about temperature, for instance. It's measured on an interval scale. We know that 30 degrees is hotter than 20, but there's no absolute zero. 0 degrees doesn't mean there's no temperature at all. It's just another point on the scale. Now let's move on to ratio data. Ratio data, like interval data, has order and a consistent scale. But here's the game changer. Ratio data has a clear starting point, an absolute zero. Consider your height. It's measured on a ratio scale. 0 height means no height at all, and 10 feet is twice as tall as 5 feet. See the difference? With ratio data, not only can we tell the order and the difference in height, but we can also tell the relative height. So, in a nutshell, the key difference between interval and ratio data lies in the presence or absence of an absolute zero. Interval data doesn't have one, while ratio data does. Understanding these nuances helps us choose the right statistical tools for our data. Remember, the better we understand our data, the better we can interpret it, and the better our decisions will be. Now, you have an even better understanding of the nuances of quantitative data. So, let's keep exploring, keep learning, and keep making sense of the world through data. Moving on, let's dive into the ocean of qualitative data. Qualitative data, unlike its quantitative cousin, is all about the qualities, characteristics, or properties of things. It's less about numbers and more about the narrative, the story, the essence. It's like painting a picture with words and concepts instead of numerical data points. Now let's talk about the two main types of qualitative data, nominal and ordinal. Remember, we're not dealing with numbers here, but rather with categories, labels, and rankings. First up is nominal data. Think of nominal as naming. This type of data is all about names, labels, and categories without any inherent order or hierarchy. Let's say you're conducting a survey about favorite ice cream flavors. The data you gather, vanilla, chocolate, strawberry, mint chip, and so forth, would be nominal data. Each flavor is a separate category, but none is inherently better or worse than another. Next, we've got ordinal data. Ordinal comes from order, and as you might guess, this type of data involves some sort of ranking or hierarchy. So if instead of simply asking for favorite ice cream flavors, you asked people to rank them from most to least favorite, you'd be dealing with ordinal data. Here, the categories have a specific order, a hierarchy. Chocolate might be ranked number 1, followed by vanilla, then strawberry, and so on. The beauty of qualitative data lies in its ability to capture the richness, complexity, and depth of human experience. It's not about counting or measuring, but about understanding perceptions, attitudes, and behaviors. Whether you're using nominal data to categorize or ordinal data to rank, qualitative data helps paint a more complete, nuanced picture of the world around us. And that, folks, is the colorful world of qualitative data. So, how do these data types make sense in the grand scheme of things? Well, let's take a step back and reflect on what we've learned so far. We began by unraveling the mysteries of quantitative data, which, as you'll recall, are numerical values that can be counted or measured. We explored two subtypes, discrete and continuous. Discrete quantitative data, like the number of pets you own, are countable, while continuous data, such as your height or weight, can take on any value within a range. Then we dove deeper into the continuous data realm, revealing two more subtypes, interval and ratio. Remember, interval data, like temperatures on a thermometer, have meaningful distances between values, but no true zero. Ratio data, on the other hand, like the time it takes you to run a mile, not only have meaningful distances between values, but also a true 0 point, allowing us to make comparisons like twice as long or half as short. Next, we unveiled qualitative data, which isn't about numbers, but about categories or qualities. We learned about nominal data, like your favorite color or type of music, where there's no inherent order to the categories. We also discovered ordinal data, like movie ratings or educational levels, where there is a clear order or ranking to the categories. So why is understanding these data types so important? Well, it's because they're the building blocks of statistics. They help us decide which statistical tests to use, guide us in visualizing our data, and assist us in making meaningful interpretations. Just think of them as the language of statistics. Once you understand them, you can use them to tell a story with your data. Don't worry if you don't remember everything. The important thing is to keep practicing and applying these concepts. Subscribe. More content is on its way and you don't want to miss it. Remember, the secret to mastering statistics lies in understanding its language, the data types. So keep exploring, keep asking questions, and keep learning. After all, the world of data is an endlessly fascinating one, and you're just getting started.